Jupiter, a name that echoes with power and majesty, a true giant among the celestial bodies. This colossal gas giant, the largest planet in our solar system, reigns supreme, dwarfing all others with its immense size and mass. It's a swirling vortex of colorful clouds, a testament to the raw beauty and power of the cosmos, constantly shifting and changing. Jupiter is a place of extremes, colossal storms that rage for centuries, with the Great Red Spot being the most famous of these tempests. Winds that howl at unimaginable speeds, reaching up to 384 miles per hour, creating a chaotic and dynamic atmosphere. And a magnetic field so vast it dwarfs our own planet, extending millions of miles into space. Jupiter is more than just a planet. It's a complex and dynamic system. It's a miniature solar system, with over 75 moons orbiting it, each with its own unique characteristics. Some of these moons, like Europa and Ganymede, are believed to harbor vast oceans of liquid water beneath their icy surfaces, potentially even harboring life, making them prime targets for future exploration. Jupiter's sheer size and influence make it a fascinating subject of study, drawing the attention of astronomers and scientists worldwide. And its magnetic field is one of its most intriguing features, offering insights into the planet's internal structure and the dynamics of its atmosphere. We can't see them, but magnetic fields are everywhere, surrounding us in ways we often don't realize. They are invisible forces that influence our world in countless ways, from the natural phenomena we observe to the technology we use daily. From the simple compass that guides our way when we're lost, to the complex electronics that power our lives and keep us connected, magnetic fields play a vital role. But what exactly are they? Imagine a bar magnet, a common object that can help us understand this concept. You can't see it, but it has two poles, a north pole and a south pole, each with its own unique properties. These poles create an invisible field around the magnet, a region where magnetic forces can be detected and observed. This field is what we call a magnetic field, a fundamental force of nature. Now, imagine that bar magnet expanded to an enormous size, larger even than a planet, stretching across vast distances. That's the scale we're talking about with Jupiter's magnetic field, a colossal force that extends far beyond the planet itself. It's a force of nature that dwarfs anything we experience here on Earth, a reminder of the immense power and mystery of the universe. Jupiter's magnetic field is a monster, a colossal bubble of magnetism that stretches millions of miles into space. If we could see it with our own eyes, it would appear larger than the full moon in our sky, even though Jupiter is much farther away. This magnetic field acts as a giant shield, protecting Jupiter from the constant bombardment of charged particles from the sun, known as the solar wind. These particles, if they were to reach Jupiter's atmosphere, would strip away its upper layers over time. But Jupiter's magnetic field stands strong, deflecting the solar wind and creating a protective bubble around the planet called the Magnetosphere. This magnetosphere is a turbulent and dynamic region, filled with charged particles trapped by Jupiter's magnetic field. Earth has a magnetic field too, one that protects us from the sun's harmful radiation. But compared to Jupiter's, our planet's magnetic field is like a tiny refrigerator magnet next to a giant electromagnet. Jupiter's magnetic field is about 20,000 times stronger than Earth's. That's strong enough to stretch all the way to Saturn's orbit when it's at its farthest point from Jupiter. Imagine that! A magnetic field so powerful it can reach across hundreds of millions of miles of space. This immense difference in strength is due to the different ways Earth and Jupiter generate their magnetic fields. While Earth's field is generated by its molten iron core, Jupiter's field is created by the movement of metallic hydrogen deep within its atmosphere. The Moon, our closest celestial neighbor, presents a stark contrast. While both Earth and Jupiter possess robust magnetic fields, the Moon's magnetic field is almost non-existent. It's so weak that scientists believe it's a remnant of a much stronger field that existed billions of years ago. This lack of a global magnetic field leaves the Moon vulnerable to the solar wind. Without a protective shield, the solar wind constantly bombards the lunar surface, stripping away any trace of an atmosphere. The moon serves as a reminder that not all celestial bodies are blessed with a strong magnetic field. It also highlights the critical role that these fields play in shaping the evolution and habitability of planets and moons. Deep within Jupiter's swirling clouds lies the secret to its powerful magnetic field. Unlike Earth, where the field is generated by its molten iron core, Jupiter's field originates from a unique source, metallic hydrogen. Under the immense pressure and temperatures found deep within Jupiter, hydrogen, the simplest and most abundant element in the universe, undergoes a remarkable transformation. It becomes metallic, capable of conducting electricity. This metallic hydrogen, flowing and churning within Jupiter, acts like a giant dynamo, generating the planet's colossal magnetic field. It's a testament to the strange and wondrous states of matter that can exist under extreme conditions. Jupiter's magnetic field doesn't just surround the planet, it carves out a vast cavity in the solar wind, a protective bubble known as the magnetosphere. This magnetic field is one of the strongest in the solar system, second only to the sun's. This magnetosphere, extending millions of miles into space, is a dynamic and turbulent region, shaped by the constant interaction between Jupiter's magnetic field and the solar wind. The sheer size of this magnetosphere is mind-boggling, as it could easily encompass the entire planet of Saturn within its boundaries. Think of it like a giant windsock, constantly being buffeted by the solar wind. The solar wind, a stream of charged particles emanating from the sun, continuously pushes and pulls at this magnetic bubble. On the side facing the sun, the magnetosphere is compressed, while on the opposite side, it stretches out into a long tail that extends far beyond the orbit of Saturn. This tail, known as the magnetotail, can reach lengths of over 600 million miles. Within the magnetosphere, charged particles from the solar wind and from Jupiter's volcanic moon Io are trapped and accelerated by the planet's magnetic field, creating intense radiation belts that would be deadly to unprotected humans. These radiation belts are so powerful that they can damage spacecraft and pose a significant challenge for any future missions to Jupiter. Studying Jupiter's magnetic field isn't just about marveling at its size and power. It provides us with a unique opportunity to understand the fundamental principles of planetary science and the dynamics of magnetic fields in the universe. By studying how Jupiter's magnetic field interacts with the solar wind, we can learn more about how stars and planets form and evolve. We can also gain insights into the processes that drive space weather, which can have a significant impact on our technology here on Earth. Jupiter's magnetosphere also serves as a natural laboratory for studying plasma physics, the study of electrically charged gases. This field of research has applications in a wide range of areas, from fusion energy to astrophysics. Our exploration of Jupiter's magnetic field is far from over. Spacecraft like NASA's Juno mission continue to orbit Jupiter, collecting valuable data on its magnetic field and magnetosphere. Future missions may include probes that will venture even closer to Jupiter, flying through its upper atmosphere to study its magnetic field in greater detail. These missions will help us to unravel the remaining mysteries of Jupiter's magnetic field and its role in shaping the Jovian system. These missions will not only deepen our understanding of Jupiter, but also provide valuable insights into the workings of other gas giants in our solar system and beyond. Jupiter's magnetic field is a testament to the power and beauty of the cosmos. It's a force of nature that dwarfs our own planet's magnetic field, protecting Jupiter from the harsh realities of space and creating a dynamic and turbulent region around the gas giant. By studying Jupiter's magnetic field, we gain a deeper understanding of the universe we live in. We learn about the fundamental forces that shape planets and stars, and we gain insights into the processes that drive space weather. As we continue to explore our solar system and beyond, Jupiter's magnetic field will undoubtedly continue to captivate and inspire us, reminding us of the vastness and wonder of the cosmos.